Let's head on over to the maps folder and we're going to open up the game map. So we're now inside of the game map. Let's add a player start. I'm just going to drag this into the level. Now under its details panel, I'm going to zero it all out to make sure it's in the center of the world. And on the Z axis for location, I'm going to set that to 10. Next, let's add our CPU player into the level. So I'm just going to go over to player, and we can see that we have our CPU player here. Let's drag him into the level. And I'm going to zero him out, like so. And for his Y, for the Y axis, we're going to put in 187. And for the Z axis, it's going to be 10. Okay. Let's add a couple of block walls to the level. So you can see that we have our block wall actor here. Let's drag him into the level. I'm going to zero it out like so. And then for its location X, I'm going to put in 169. And the Y can be 0 and the Z is going to be 0. For its scale Y, I'm going to scale it to 14. And its scale Z is going to be 2. Like so. I'm going to duplicate this. I literally just clicked it, held down the Alt key, or the Alt key, drag off it like that, and it duplicates it. Now the X-axis for this is going to be negative 172. The Y and the Z axis for the location are going to remain at 0. And the scale is also going to remain the same. Let's adjust the CPU player actor. I'm going to click on it and hit Edit Blueprint. Open Blueprint Editor. This looks like it checks out. Now the win box is actually on the wrong side. So instead of negative 602, change it to positive 602, like so. And these collision boxes I'm going to select scene. And I'm just going to make sure that it's on the right side. So I'm going to click select scene and just move it so that it's on the opposite side of the win box. So win box should be to the left and the scene with all of the smaller collision boxes attached to it should be more to the right. So that's just a minor adjustment that we've made. or that we need to make. So we compile that. If we head back to the level, what we should have is the player should be on the side facing the collision boxes on the CPU player. So we can see the collision boxes are here, players there, and the win box is behind the CPU player. So essentially when the ball gets past the actual paddle, the player will score a point. Let's reopen the CPU player once more, because there is a very important adjustment we need to make. Now, if we take a look at the scene component, we notice that it's at 46. Now, there's a variable down here called collision box sides. If we click on that, it has two elements. One's -46 and 178. Now, this is basically the it controls which side these collision boxes will be on. So if we go back to the scene and make sure that the Y is -46, really the collision boxes should be on the right side of the paddle. So I'm going to select all of the collision boxes and I'm going to move them over to the right. So let me just make that adjustment. Might have to do it one by one. Like so. So now remember that the collision box sides elements, one's -46 and 178. So under the scene, on the scene component, this is the component that we're going to use to control which side the collision boxes will be on. So if we change this to 78, it would flip over to the left side. And if we switch it back to -46, it would go back to the right side. -46 is the default value for it, as that's the first element inside of the collision box sides array. I'm just going to compile this and save. We can head back to our level. Let's set up the game mode. So I'm going to go over to world settings, and if you can't see world settings, you can find it by hitting window and then go down to world settings. Now under game mode, if you can't find that, just do a search for game. We're going to change the game mode to our Pong game mode. Okay. Now the default pawn class is correct. It's using the player_BP. Let's make an adjustment to the color material. So we're going to go to the color mats _matte that we made. And I'm going to plug this into emissive. And I'm going to hit apply. So just for testing purposes, what I'm going to do, I'm going to go to paddles, material instance, and I'm going to change the color of it to, I don't know, green or something. And if we play the game, we should see two paddles with the same color. Brilliant. Now, the camera inside the player is perspective. We're going to change that to orthographic. So if you go inside of player BP, you're going to take a look at the camera, and we're going to switch the projection mode to orthographic. Just going to hit compile, and I'm going to hit play to see what that looks like. It's much better. You get a nice flat image, no perspective. Let's set up the input so that the player can move their paddle. Remember that on the project settings, on input, the move up key is W and the move down key is S. And the input mapping name is move up for moving up and move down for moving down. So we're going to head into player BP, and we're going to head on over to the event graph. Okay, so let's delete all of these. Don't need them for now. And if we right click and type in move up, you notice that we can see our move up axis event. Let's click on it. So here is our axis event for moving up. We need a condition, so I'm going to hold down the B key and left click. Alternatively, you can right click and type in if, and it will be a branch, or you can just do a search for branch. Same thing. Just going to drag that execution pin here onto this, and we want to check if the player is ready. So we're going to get player ready. But for now, because we're testing it, we just want to make sure this is always true. I'm just going to drag player ready here. So we're going to get player ready. Just leave it disconnected for now and leave this true. Now what we're going to do, we're going to do a check for the cube's Y offset. So we're going to get the cube and just drag it in. And we're going to get world location. And we're going to right click on this vector here, this output vector. And we're going to split struct pin. Now what we want to do, we want to do another condition. So I'm going to hold down B, left click. I'm going to connect true to this. Just resize this. And what we're going to do, we're going to say if the x-axis value is less than 116. So if it's less than float, so float less than float, I'm going to put in 116, 116. If that is the case, then we're allowed to move up. So we're going to add world offset. So we're going to get the cube, drag off that pin, and add world offset. So that's true. We're going to add the world offset. And the offset we're going to use is the value that comes out of the axis value on the move up input. So let's go over to the input vector on this add world offset function. Just going to right click on it, and we're going to split the struct pin. And this axis value is going to go straight to the X on that function. I'm just going to compile that. So that's the move up finished. Let's set up the moving down input events. So I'm just going to right click and going to type in move down. You can see that we have our axis event for moving down. I'm going to click on that. We're going to need a branch, so I'm going to hold down B, left click. And again, this branch is for whether the player is ready or not. But because we're just testing it, we want to leave this as true. Then next, we're going to borrow this. So let's highlight all of this. Hold Control and click on this branch here. Come down here and I'm going to press Control W to duplicate it. Like so. This is going to go to this. And what are we checking for here? Well, we're going to check if the x-axis for the cube, or the x offset for the cube, is greater than negative 116. Up here it was positive, less than positive 116. Down here it's going to be if it's greater than negative 116. So more than, so float, more than float, negative 116. And this is going to go into this here. Now if this is the case, then we're going to add world offset. So I'm just going to click on this. I'm going to press Control W to duplicate it. If that's true, go in here. We're going to get our axis value, and we're going to connect this to the x input parameter on this function. So I'm going to compile this. Just make sure that the cube is the target for that function. Now we're good to take this for a test, I think. So I'm just going to go over to the game map and I'm going to press play. F11 for full screen. I'm going to press W to move up, and it only goes up so far. And I'm going to press S to move down, and it only goes down so far. So I'm literally holding down W and it stops right there. And I'm going to hold down S and it stops right at the bottom of the screen right there. So it's working. Let's add a comment for our nice input that we created. So I'm going to head back to the player underscore BP. And I'm going to plug this player ready in now because we know it works. So let's connect this. And likewise with this one. So by default, the player will not be ready. And the reason we do this is because we want to interact with a menu before the game begins, or whenever we score. It makes it easier for us to pause the game and then switch it back to a reset state. You'll see what I mean later on. So I'm going to drag a box over all of this, and I'm going to press C to add a comment, and we can call this something like input events. So these are our inputs. Let's set up the logic that will serve as the backend that would allow the player to choose which color they want to be and which side they want to be on. So I'm going to make a new custom event called setup game settings. Okay. So I'm going to right click in the graph and I'm going to make a custom event, and I'm going to call this setup game settings, like so. This event will check whether the player is ready. So I'm going to hold down the B key and left click, connect these two. We're going to get player ready and drag it in onto the condition pin. we're going to add a do once. So I'm going to drag off this true pin and I'm going to type do once. Click do once. And we're going to set what side we're going to be on based on the index selection or side index selection. Because remember, on sides, the first element, which is 0, is negative 187, and the second element, which is 1, is positive 187. Left and right is actually on the y-axis, because if you look in the map in the bottom left corner, you can see that left and right is y and up and down is x. Now, this is the way the project has been set up. It's a personal preference. I recommend following the way I've laid it out so that there's no confusion. But there's no fixed rule of saying what will be up or what will be down in a game. It's just that it needs to be chosen at the start, and you have to just follow through all the way to the end. So back in Player BP, we're going to add a few nodes that will control which side they'll be on based on this side's variable. So let's grab our cube. Just going to grab him in, drop him into the graph, and from this do once node, we're going to connect it to something. So I'm going to drag off the pin from the cube node or cube variable, and I'm going to set relative location. Now the reason why I'm setting relative location is because the location needs to be set relative to this specific actor and not to the world. So yeah, it's going to connect this to this like so, and for this vector input parameter on this function, I'm just going to right click it and I'm going to split struct pin. Then from this cube, what we're going to do, we're going to get world location. I'm going to right click on the output parameter, split struct pin, and we want the current X and the current Z because I don't want to manually input them. But the Y, which is which side it's going to be on, is basically going to be sides. So I'm going to drag sides into the graph, get sides, and then we're going to get. So just drag off that pin and type get. I'm going to get a copy. So which element are we getting? Are we getting 0, which is negative 187, or are we getting 1, which is 187? Well, that's entirely up to the player. So that's where the side index comes in. So we get side index, and we're going to connect this to the whatever this is, the index that we're referring to, and the output of that is going to go into Y. We have to do the same for our collision boxes. Remember that the collision boxes are actually attached to the scene component. So when we move the scene component, it will move the collision boxes. So I'm going to go back to the graph and I'm going to drag in the scene component. And we have to make sure that we can set which side the collision boxes will be on. So again, we want to set relative location. I'm going to select this function node here and I'm going to press Ctrl W to duplicate it. Just going to connect the output of this into this execution pin. I'm going to connect this to the target. And again, if we want to get world location, I'm going to select this node here, press Ctrl W to duplicate it. I'm going to connect this to this. So the X and the Y, and the X and the Z, sorry. So X goes to X and Z goes to Z. But for the Y, we have our values for collision box sides. So I'm going to drag this in, like so. We're going to get it. So we're going to get a copy. And we're going to choose from side index, which is what the player will be able to select, either 0 or 1. Because in collision box sides, we have 98 or 72. So if we go to the scene, it would be either one of two. So if you set this to negative 72, to see that they're actually it's actually offset here. So we're gonna have to adjust this a little bit. So on the y-axis, we could probably get away with zeroing it out for all of these collision boxes. So mid box, its y location is going to be 0, and the low box is its y location is also going to be 0. So I've basically set for all of the collision boxes, I've set their y location to 0, because I'm entirely using the scene to control its y position. Because in the collision box sides, the scene can either be one of two positions, 98 or negative 72. 98 is on the left side of the paddle, and negative 72 goes right over to the right side of the paddle. You can experiment with it. You can change the values to a value or position that you want. But for now, this works. So in collision box sides, the first element is negative 98. So what I'm going to do, I'm going to match the scene Y location to the default value, which is 98. Positive 98. Okay, so back in the graph, I'm going to connect this collision box sides to this new Y location, like so. So that's all good. So scene can either be one of two positions, not negative 98, positive 98, and negative 72. To the left or to the right of the paddle. Okay, so moving on. We're going to set up our Winbox side. So again, we're going to click on set a relative location. We're going to duplicate this. And as a matter of fact, we want to actually recombine struct pins. So I'm going to click on one of these float parameters, and I'm going to recombine the struct pin. And I'm going to get the Winbox, I'm going to connect this to this node here, like so. And I'm going to get the Winbox sides. I'm going to get it, get a copy. And the sides, again, will be either 0 or 1 from the side index. And this will go into the new location. Now, let's just double check this. So Winbox is this nice big box here. It's what happens if the computer scores against us. If we were to take a look at the actual values inside of that, the first value is negative 507. So let's check this. And this is supposed to be the y-axis. So negative 507. That's looking good. And on the Winbox sides, the second element is positive 507. So if we switch this over to positive 507, it should flip over to the right like a mirror. Great. So it goes to the right side of the paddle, which is good. So that's fine. It works. I'm going to switch this back to negative 507. Because remember, the parent is the cube. So it will go to the right side of the cube. And if the cube was to be on the other side, it should be somewhere like over here. So right now it's negative 187. If it was positive 187, it will flip right over there, which is correct. So I'm going to switch that back to negative 187. So yes, this is working, or it should work. Okay, so now we're going to take a look at what color the player will choose. All right,